That looks good. Got it. Admit. And over here. And so welcome, everybody, again to Big Data here for our topic 4 SQL stuff that we started on Tuesday and will continue today. Last Tuesday, what we talked about was in this topic 4 SQL folder in a repository, there's this SQL quiz Git submodule, and we haven't talked about all the material in that quiz, but we did talk about just how to get it up and running with the Docker Compose to get Postgres working and SQLite to get connected to both of those two databases so that you can start working through some of those problems. And we only worked through like the very first topic there, very beginning sort of stuff. Next week, we will do a little bit more with this SQL quiz, but not too much more. Most of the things in this quiz I'm expecting are reviewish enough that you'll be able to sort of figure out things on your own. But next week we will talk more about the SQL quiz, especially sort of the last half where it's talking about joining tables together. Today we're going to be focusing on this pagila homework Git submodule and how to use it. We went through over here this first part of the lecture notes, all this high-level stuff, and then we haven't fully gone through this what you must know for the homework midterm yet. Again, there's this web page, postgresqltutorial.com. Normally I say Postgres without the QL over here, but Postgres and PostgreSQL are sort of synonyms for each other. You'll see people write it both ways. So sometimes you'll hear people talk about PostgreSQL or just Postgres. The tutorial stuff here is, again, the material that you'll need for the quiz and also for the homework. And it's, again, the first 4 sections that we will be covering. Let's admit into the class over here and back over here. Okay, so that's what we're going to be doing today at a high level. Maybe 2 really quick announcements before we actually do that, though. The first one is about grades and grading. I've started grading your homeworks that were due last Tuesday. The Twitter coronavirus one in particular, that is all graded for everyone who has submitted so far. And then I haven't started the Flask on Docker yet, but that'll be done today or tomorrow. And again, if you haven't submitted yet, that's totally okay because of the way the exponential decay works. At this point, if you submit today, you still only lose 2 points on the assignment, which is not even a letter grade. And so again, the exponential decay is designed so that you have this sort of extra flexibility in choosing when you want to turn things in. I remember when I was a student, my CS department did that, and I really liked it, and I don't think I ever turned in a single homework assignment on time because of just getting 1 point off was not a big deal. So I certainly have no hard feelings for anybody who chooses to do that as well. So that's first announcement. Another sort of fun announcement, I posted this as an issue in our repository here, but there's some fun-ish internet drama that I thought we might talk about here. Happened over the last day. So again, Nginx, this web server that you were using on your Flask on Docker assignment is currently the most popular web server on the internet, and it literally has 2 people who are the maintainers of this. These 2 people maintain this critical software that most of the internet runs on. They're Maxim Dunin and this guy named Megazone, which is his actual legal name. And the drama is that recently Megazone decided to issue 2 things called CVEs. That stands for the Common Vulnerabilities and Exposures. It's a database of all of the major bugs or security issues that exist in software. Maxim didn't think that the bugs that existed in the software warranted a CVE being issued. And so he rage quit the project, created his own fork, which he calls Free Nginx, and that's now available at this website. The two projects are identical at this point. It's not clear, though, in the future which one might end up being the most popular. My hot take conspiracy theory on this is that Maxim Dunin is a Russian, and he's still living in Moscow. Everybody else who's been working on the Nginx project has left Moscow after the invasion of Ukraine. And in particular, the company F5 that was sort of shepherding this project has pulled out of Russia because of these sanctions issues. And so, and because Nginx has been this Russian project, I think it's sort of been an embarrassment to the American intelligence community that this Russian project runs so much of the internet. And so it wouldn't surprise me if various behind-the-scenes CIA, NSA sort of people have been secretly trying to make things like this happen, rift in this project, and are celebrating popping their champagne corks this morning. Other unrelated news, but also related to Nginx, is there's this ISP called US Internet, and they accidentally leaked all of their customers' emails to the internet. These are emails going back to 2008. And the reason this happened is because of a misconfigured Nginx file and this thing called Ansible. Ansible is basically just Docker Compose, a slight alternative to it that's a little bit more flexible. Ansible can do everything Docker Compose can do, but Docker Compose cannot do everything Ansible can do. And they misconfigured these two systems, which, as you've seen with your Flask on Docker assignment, is extremely easy to do. Their particular misconfiguration involved just exposing some ports that they didn't think were exposed to the internet, which, as you've seen from your Flask on Docker assignment, is very easy to do, to not understand what your port forwarding and everything is doing. And so one of the main, I guess the takeaway from this is one of the main causes of security vulnerabilities, leaks of information on the internet, is not because of hackers have done something super clever to get your information, but because the programmers who were implementing your infrastructure have done something which in retrospect was super stupid, but was very easy to do because it's very easy to make mistakes. Okay. We'll switch over here to this Pagila homework assignment here in a second. Before I do that, any questions about anything in the class so far, administrative or anything else? Mouse.
I'm just a little confused how exposing the port allows access to it. I mean, there's sort of like measuring for avoidance.
Yeah, so the question is, how exactly would exposing a port do this? Roughly, they had an admin-only service that was only for internal use, and they accidentally made that port available to the entire internet through various port forwarding things. There are more technical details if you would like to read them inside of this link right here. It'll take you to. So again, this Hacker News website has lots of discussion. This Krebs on Security website is one of the most famous sort of high-level security vulnerability websites there are. And it goes through like step-by-step exactly who discovered this, how they discovered it. And so here you can see that the web page that was actually made available on port 81, one of these non-standard ports. So that's why it wasn't discovered until recently. And actually, yeah, maybe one of the things I haven't mentioned so far, but one of the reasons this is super embarrassing to this company is because they advertise themselves as a secure email provider that a lot of government agencies and businesses that you've heard of were using their secure email service, which was not secure at all because all the emails are public. And so there are likely to be like fallout court cases of these other places suing for negligence against this company. But yeah, if you're interested in technical details, this has the whole write-up of exactly what happened. Good question. Okay, so today we're going to talk about this Pagila homework and how exactly to use it to complete your homework assignments. And in order to do this, I'm going to first switch over to my terminal over here. And you can see that I'm currently connected to my laptop. Normally, I've started off all our class sessions connected directly to the Lambda server, but I'm just going to walk through how I personally connect to the Lambda server right here to illustrate, I don't know, how all this scripting stuff that we've been talking about, how I use it on a daily basis. So in my home folder, I have a folder called scripts, which contains a bunch of shell scripts that do different things for me. One of those is this VPN script, and it runs this big incantation that I use to connect via Open Connect to our VPN here. And so I have to do sudo sh script / vpn.sh. Again, sudo, not something that you've ever had to run before for this class. It stands for SU is switch user, normally used to run things as a root user. Switch user actually changes your user account to root. SU do, the do is like actually do something. So switch user and do something. The thing that I'll do is connect to the VPN. I have to be the root account in order to do that. So I will type in my passwords really quickly here. First one for the VPN, next one, or sorry, first one for root, next one for the VPN access. And now I'm connected over here. I'll switch my virtual desktop. I like to use systems that have many virtual desktops. In the top left corner up here, you can see which virtual desktop I'm And okay, I'm not muted. That's good. Let's share my screen again. Allow that. And it looks like it's still recording over here, so I won't mess with that. And then back over here to my terminals. But yeah, so whenever I'm working on any remote server, I basically always have at least 2 connections going at once. One where I can use Vim, say, to open things like the Docker Compose file, and another one where I can run different commands down here. There are ways to do similar things like this purely in a single terminal session. The popular commands are tmux and screen. Lets you sort of split one terminal session into multiple different environments. I don't personally like them, but other people do like them. For me, it's simpler just to open up multiple terminals and connect with multiple sessions. Good question. Any other questions about where we're at so far? Henry?
We should have, well, we should have forked.
Question is forking the repo at the very beginning. Should we have done that? The answer is that it doesn't matter at this point whether you've done that or not, whether you have forked or not, but eventually you're going to have to, as part of this project, make some changes to some files and upload them to a repository on GitHub. And so if you didn't fork, you can still follow along with everything that we've done so far. But once you get to the submission stage of the project, you'll have to fork and upload to the fork. Did that answer the question?
Yeah.
Great question so far. Any other questions about where we're at, what's going on? Okay, let's move that out of the way. Okay, so yeah, before we start working on parts of the homework, let's just go over at a high level what the structure of this project is. And again, anytime you see Docker, that is a good first step. And actually, maybe before I do that, one last high-level note about this project is that if we come over and look at the actual Pagila project, so this, I'm looking at the repository that is not my repository, but this person, Devrim Gunduz, whoever that is, his repository. And we come down, I want to notice in the documentation, you'll see that there's a section on creating a database on Docker. And these days, say in the last 5 years or so, maybe up to 10 years, anytime you see some like an open source project that involves that involves Postgres, you're guaranteed to see an explanation about how to get that project up and running with Docker. And all these commands about Docker commands should look fairly familiar at this point about doing that. You'll often run into situations where there will be like weird incantations that you won't know what all those things are doing, and the instructions are likely not to explain what all those things are doing. But very, very standard for Docker to be used on any project with Postgres these days. And Docker, again, not used just with Postgres, but you'll see Docker on lots and lots of systems, lots of GitHub repos, for example, about how to get started with those systems. So that is one of the things that skills you will hopefully find useful after this class going on through your long and illustrious careers. Okay, back to the homework. Again, I'm in the Pagila homework folder that I cloned, and up here I've opened the Docker Compose file. And we can see that there's just going to be one service in this file, which is called PG. It is built from the dot folder. That means the Docker file will be contained in the dot folder, in the current folder. And we can see that it is in fact contained in the current folder. Right here, I have the Docker file in my project root. And so up here, let's go take a look at that file. I'll do :tab-E, D tab to open up the Docker file, again in a separate tab inside of Vim, so I can switch back and forth with the GT keys, GT, switch back and forth between tabs inside of Vim. And here in this Docker file, we can see we're loading Postgres, installing some stuff, and actually this Docker file here is almost exactly the same as the Docker file for our quiz. The only difference is that it's different data down here that is being loaded into this location right here, which the database uses to create the database, which Postgres uses to create the database and load files, load data into the database. You won't have to mess with any of these files, but you won't have to mess with any of the Docker things, but it might be useful just to look at them to see exactly what's going on. And again, we have a bind volume here, which binds our current location that we're inside of down here, pagila homework, into the database, into the container that hosts the Postgres database. And so because we have this bind volume, I'll be able to just directly edit the problem files inside of the Lambda server without having to go inside of the container to edit them. So that'll be useful for us. And then the environment variables, here again, things that Postgres just needs to get started. You won't have to worry about those at all. Let's open up the README file again, tab E README down here. I'll use my / key for search, /search, and I will search for the Docker compose instructions that we're seeing. So here, this is in the tasks section right here in tasks. And we've so far gone through all of this task 1 right here of setting things up. And I haven't done this modify the readme.md file so that the test case image points to your forked repo. That's again something that you had to do from your first homework assignment in this class, getting things set up with continuous integration. And we won't go over that in class. Maybe I will say though that, so the last 2 homeworks that you've had since the very first homework, they did not have any continuous integration along with those homeworks. And a number of you asked excellent questions that basically are summarized as, how do I know if my submission is correct? And you didn't specifically say without continuous integration, without test cases, how do I know if my submission is correct? But that's the implication, that if you don't have test cases while you're developing things, you can never know if your stuff is correct. And so now that we are switching over here, we will have some test cases for you, which will make it much easier for you to know if your submissions are correct. And that's one of the reasons that students tend to find these next couple weeks much easier than the previous 2 weeks, is because you'll have these guide rails of test cases for you that will do this. Okay, so the next instruction here, solve each of the problems in the SQL folder. Let's go over what the structure of our project actually is now. There's this, so we've seen this pagila folder, that's where the data is contained. There's this SQL folder right here. I'll do ls/sql in order to see that. You can see that there are 20 different files down in this folder, and each one of those files is one problem. Some of those files have very similar names, similar numbers. But these are 2 separate files, so 2 different problems just very closely related to each other. And the idea is that each one of these has described something that you should do in SQL, and you'll have to do that thing in SQL, and the test cases will make sure that you have done that thing in SQL. So let's go ahead and I will work through a couple of these problems in class, so you'll have a couple of the solutions just pre-given to you. And again, you're welcome to follow along right now so that you can just make sure that you can follow this through the steps of how to complete these problems. And in this case, you'll actually get the answer to a handful of problems while doing so. So this first problem, 01.SQL, let's open that inside of Vim. And again, anytime you're opening a file, you don't want to cd into the folder where you're opening that file. You want to stay in the project root and open it from the project root. The way you do that inside of Vim, so I'll do :tab-E to open up a new tab, and then it'll be SQL/ the file that I want to open. Anywhere where you can type in files, you can type in paths. And so whether it's a relative path or an absolute path, doesn't matter. I'll open up this relative path from the root of my project into the SQL folder /01.SQL file. And here are the instructions for what to do for this problem. We'll go over these in a second, but before I do that, I want to make a connection down here in the bottom terminal to my Postgres database. Let's do docker ps in order to see what's running. I can see that I have a lot of things running right now. Probably you all still have a lot of things running as well from your previous projects, so I'm going to go ahead and close all of these things that are running. We'll do Docker. So we already ran Docker PS to list all of the things that are running. I could do something like Docker stop and then manually cut and paste all these container IDs over here, but that is such a hassle. I don't like doing things manually, so I'm going to automate this process and just automatically kill everything. In order to do that, I will use Docker PS, and we'll see this -q parameter right here. -q stands for quiet, and it's quiet because it only lists the hash of all of our containers that are currently running. So Docker PS-q only lists the hash of the containers that are running, q again for quiet. And this is going to be very useful inside of shell commands when you want to run shell commands on the containers, because it gives you sort of the identifier of those containers. In this case, the shell command that I want to run is stopping those containers, and I'll use my command substitution right here in order to do that. So Docker PS-q like this. Again, we've seen that Docker PS-q is equivalent to all of the container IDs, all these hashes over here. And so we're passing those, substituting those hashes right here inside of the shell, and we'll run Docker stop on all of those hashes like this. Now, if I run Docker PS, we can see that everything is in fact stopped. And so I can bring something else up without cluttering my set of containers down here. This will be a very useful incantation for you going forward in class. Not something that you're ever required to run, but useful for you to clean up your old projects and sort of get started on a new, on a fresh Docker system. One last maybe Docker trick that I will do for us real quick. I'll do a Docker PS instead of -q, I'll do -a. Again, -a stands for all, and it has a similar effect as the ls-a. It shows hidden things. Anytime, sort of the custom convention is that anytime you have a shell command and you want to have hidden things versus non-hidden things, you have the -a flag to display those hidden things. And if I run that, you can see that I do have a number of hidden containers down here. That it turns out that the Docker stop command stops those containers, but it does not delete those containers. It does not remove those containers. And in order to remove those containers, you use the Docker rm command. And so now after running Docker stop, I will run Docker rm with all of these hashes. In order to get those hashes, instead of just -q over here, I'll do a qa, so we get the hidden ones as well as the non-hidden ones, and pass those to rm. And now there's actually a clean Docker system, nothing running actively and nothing just taking up space on the system, paused in the background. Any questions so far? Yes.
What's the difference between $$ using a $sign and $?
Question is, what is the difference between the $sign up here and piping? And the answer is that the $sign up here is going to substitute things on the command line itself. So this right here, this was equivalent to Docker rm and then actually pasting in these hashes, something like this. Piping never puts things on the command line, it puts things into standard input. So some commands expect things on the command line, some commands expect things on standard input. The Docker rm over here doesn't use input at all. And so for Docker rm, it has to be with the command substitution like this. Other programs have to be, like grep would have to be substituted with piping. Both ways of providing inputs to a program on the command line, they just provide that in different locations. Oliver first.
I missed why you added the Q.
Question is about the Q and the A over here. So I will run these commands again, although they won't display anything anymore because I have deleted all these containers. But Docker PS by itself, again, provides the human readable output. Docker PS-q, the Q stands for quiet, and so it provides only the container IDs. The container IDs, we get nothing right now because there are no container IDs to display. The Docker PS-a stands for all, lists the hidden things, not just the actively running things. Again, there's nothing running right now or hidden. We just deleted it all, so that's why we get nothing down here. -a-q combines these two things so that we get the machine readable output, the Q for quiet, also machine readable, and then the A for listing hidden things as well. So that gives all of the hashes of things that are running. Happens to be that there's nothing running right now, and Q gives them just in hash form and not the human readable form. Ainsley? Question is, how is this different than Docker Compose Down? And the answer is that Docker Compose Down will run both the stop and the RM commands for us. But let me scroll up here for a little bit. Okay, here, this is the output right here of running Docker PS a couple minutes ago. And we had 4 different containers right here that were stopped containers. And if I was in the project that had the appropriate Docker Compose file, then those containers would have stopped. But because I'm in the current project and in my current Docker Compose file, all I have is a PG service. If I were to run Docker Compose down, the only thing that it would try to stop is the PG service and not all of the other services that were also running. So the Docker Compose file, you could have, for example, 20 different projects, each with their own Docker Compose files running, and they will never interfere with each other. Docker Compose is designed so that it will never interfere across project boundaries. But in this case, I wanted to close everything across all project boundaries. And so you can't do that with Docker Compose. You have to go back to straight Docker to do that. All great questions. If you have more sort of Docker questions, I'd be happy to answer those offline after class or some other time. Okay, so I'll reset my terminal down here, clean things up a little bit. Let's stay organized, and let's enter pSQL connect to the database so I can work on this problem 1 over here. And so I will do Docker compose exec pg pSQL. Again, what's going on here is, where's my mouse? There we go. PG is the name of the service that I am trying to connect to. Exec is the thing that I am doing to this service over here. So I'm running a command on the service that is currently live. And pSQL is the name of the command that I am running. And pSQL is the standard command to connect to the database. Here we get nothing happens because, again, when I do Togger PS, I don't have any containers running. I forgot to bring up the containers. I did get this warning message up here about cryptography related stuff. This is because I'm using the old Python 3.6 installed on the Lambda server. And so this happens every time that I run the Docker Compose command. Let's do a Docker Compose up -d -- build like this and bring everything up. And And then once this is complete, I will be able to use my up arrow, up arrow, up arrow, go back to my pSQL command, hit enter, and I am now, in fact, connected to the Postgres database. One of the sort of administrative pSQL commands that you saw in the Flask on Docker assignment was this \DT listing all of the table information about the database. And so you can see that this is a much larger database, has many different tables inside of it compared to the Flask on Docker database. If I go back over to my README file on GitHub, and what I want to take a look at is this big picture right here. This picture is a standard way of summarizing databases. And each one of these sort of boxes corresponds to one of the tables in the database. The top box, it's like the title of each box is the name of the table, and then each of the rows down here is one of the columns inside of the table. We'll talk about all the other features of this picture as they become important, but at this point, the thing that's important is just each box is a table, and there are rows inside the box that show us the names of the columns. Come back over to my terminal windows, and now I'm going to switch over to my 01.sql file. I could press GT like a sucker to get over there, having to press that 4 times, switch so many tabs, or I can scroll the other way, going left instead of right. In general, anytime on Vim you're going to the right, you're going forward, it's always lowercase, and anytime you're going to the left, you're going backwards, it's always uppercase. So I'll do G-Shift-T, G-capital-T to move my tabs to the left and take me to the tab that I want a little bit faster there. And again, each one of these, what this file is it is one of our problems stored in this SQL folder. And we're going to, what you have to do in the homework assignment is open up all of these problems and write an appropriate SQL command right here that answers this problem up here. And so let's do that now. So this problem says display the first and last name of each actor in a single column in uppercase letters. In this case, I'm not giving you any hints about what sort of tables to look at. Some of the future problems will provide you hints about things, but I'm expecting you to think, okay, I'm looking for actors, so I should look in these tables to the one that probably has the information related to actors. And in this case, there happens to be a table named actor, so that looks like a great place to look. Right now in this bottom terminal, I'm in what's called the pager environment. The pager environment lets you look at output from a psql command. And in order to leave the pager environment, you press the Q button on your keyboard, and that will instantly leave from the pager environment. I want to take a look at this actor table up again to see what is the information that I should be extracting from this actor table. And there's a couple ways to do that. One is that I can redo this /DT command specifying a table name and actually get information about the actor table itself. In this case, this is not useful information. This is the same information I was just seeing. Let's do /D actor. This will give us the actual column names. Again, I'm in the pager environment, so I'll press Q to get out of it so you can see what the command is that I typed in. /D without the T to get me actor. /D with the T gave me this sort of a little bit higher level information about the table. /D by itself gives me the lower level, more detailed information about the table. Maybe one last thing I'll say about the output here is this word relations. In SQL, you can think of relations, at least at this point, as a relation for a synonym of a table. All the tables that we're going to see, all the tables everywhere are an example of a relation, and all the relations we will see for the next couple of weeks are going to be tables. In the future, we will see other types of relations that are not tables, but at this point, every relation is a table. So think of them as synonyms. Relations, tables, same thing. Oops. And I want the /D of actor so that I can take a look at the contents here. Again, I'm a little bit zoomed in right here, so things are bleeding over onto multiple lines. If I zoom out, you can see that this column information is this one line per row over here, and each row over here has the name of one of these columns. And so this is one way that I can find out the information about what are the actual columns of a particular table. The other way I can find out is by going back to my picture over here, finding the actor table, which is down here, and seeing that these 4 rows inside of this box right here correspond to the 4 different columns inside of this /D output down here. I'll zoom back in again. Again, I'm in the pager environment, so I'll press Q to leave out of that environment. Question? Sure. So the question is that I did psql right here to enter this environment, and what was the command that I did before the psql command? It is, or the thing that I needed to do was this bringing everything up, which is this command right here. We can see that the first time I ran psql right here, nothing happened because I'd forgotten to bring up my database. There were no services running. I verified that right here with the Docker PS. There are no services running. And now I had to bring them up in order to be able to connect with psql. And after I bring them up, I get all the output from building the containers. And then I can actually connect. And once I run this command for a second time with the containers running, I get my prompt and I can type in commands. Does that answer? Great. Yep, great question. If you forget any of these steps, they are all contained inside of this README, and it has reminders about, like, this is the thing that you have to bring up. And then we haven't gotten to this command yet, but we'll get to this here in a little bit after we finish this problem. Great question so far. Any other questions? Yes.
Do we always need to pass
Sorry, passing what? Doc. Oh, okay, so the question is right here, what is this exec doing, and do we always have to do it? So that, yeah, the answer to this question is that anytime we want to run a command inside of a container, the pattern for that is Docker compose. Then the operation we're doing on that container, there are many other operations that we could do, like bring it up or bring it down. But in this case, the operation that we want to do is execute a command, so exec, and the command that we want to execute is psql. So this will be something that you will use on the homework hundreds of times probably. Very, very common command to run. Did that answer the question? Okay, now that we are connected to the database, we've seen a little bit about this actor table. We can think about actually solving this problem up here of displaying the first and last name of each actor in a single column in uppercase letters. Well, before, I don't know, maybe even starting on this, let's just break it down a little bit. Let's just actually select everything from the actor column and visualize things a little bit. Again, one of the common mistakes that students, beginner data scientists do is you just jump into solving the problem without maybe visualizing things, get a handle on what the table looks like. So a good always first step is just to select star from whatever table you think you might want to be working with to get a sense about what the data looks like here. And I guess this is also another way you can see what are the columns in the table because it lists the names of the columns up here. So the first name, the last name, and the last update, the actor ID over here. Based on the wording of this problem up here, it's talking about the first and last name. So this seems like probably the columns I'll be most interested in. And probably not have to think about these columns over here. And it's also saying that we want all uppercase letters. And fortunately, it looks like the data is already stored in all uppercase letters, so we probably won't have to do anything special to satisfy this. And so let's queue down here, and we'll do a select first name, comma, last name from actor like this. The reason I am doing this, first name, comma, last name, is because that is what it's asking for up here. It wants the first name and the last name of each actor. And I'll hit enter, and now we have this. At this point, it is two separate columns, but the problem up here says that it wants it in a single column. So I'll have to combine these columns together somehow. Again, I'm in the pager environment down here, so I'll press Q to get out of that environment. Press up arrow down in my terminal to get back to the previous command and move my cursor over. Again, I'm pressing Control to jump from word at a time instead of line at a time. And we can combine things together. The way to concatenate anything in SQL is with the double vertical bar like this. And if I do that, then we get the output that looks like this. Pretty ugly output, probably not what anybody would want to see. And a better output would be adding a space in between there. So let's put a space right there and then concatenate again with the last name like that. And now we can see that, okay, Penelope Guinness, Nick Wahlberg, Ed Chase, Jennifer Davis, and so on. And it's actually readable because of the space down here. Again, what I've done so far is just adding these concatenation operators. The double vertical bar means concatenation in SQL. And here is my space that I put between the first name and the last name over here. Any questions so far? Yes.
I noticed that like a column header, question mark, column name or something like that. We also want to specify.
Yeah. So great question. The question is when I run this command, hit enter up here, we can see that it has question mark, column question mark, that there is no name specified right now for this column header. And the question is that okay? What should we do about it? So we've only talked about this first line of the instructions so far. The next line down here is we need to name the column actor name down here. And so the column is not named after name, so it can't be acceptable as it is. So I'll press Q to quit out of that, and we'll see how to name columns next. I'll press the up arrow to get back to my previous command. Over here to the end of the column. So this is the computation that I'm doing for that particular column. Again, these computations happen on a row-by-row basis on this table over here on the right-hand side. So for each row in the table, I'll get the first name and concatenate it to the space, concatenate it to the last name. In order to specify the name of a column, the keyword is as in SQL. And again, case does not matter. Uppercase, lowercase doesn't matter. So as, and then the column name up here, actor name like this. Actor, I'll start by typing a space in there, actor space name like that. We'll see that we get a syntax error right here. And that's because the column names can only be one token in SQL. And here we have a space between, and so it thinks that the column name is actor, then it arrives at name, and it doesn't know what exactly to do with it. One of the maybe frustrating, probably one of the more frustrating things about this part of the class working with SQL is that the error messages in Postgres, and actually the error messages in every database system, are very, very horrible. So here we get error, syntax error at or near name. There's no suggestion about what to fix or what the root of the problem might be. But in this case, the problem is that it's not expecting a name. It's not expecting this space right there. So I'll start by just making this one token again with an underscore in between to solve that problem. And now you can see that we have actor underscore name up here. Notice again at this point that this column name all lowercase, all lowercase. I'll press Q to exit this environment. It's all lowercase, even though I named my column over here with uppercase letters, because SQL is case insensitive, and so it doesn't matter how I capitalize this thing over here. Actor name, doesn't matter how I capitalize it over there, it's going to appear in lowercase over here. Press Q out of that. So we've mostly solved this, and we'll come back over to this next part over here about sorting the results alphabetically. In SQL, in order to sort things, we use the order by clause. The order by clause always appears as the last thing in your select statement. So we have select, all of this stuff. Then after the from actor, we put in order by like this, and then the columns that you want to order by. I'll start by, we'll see just first name like this, and I'll hit enter. And now we can see that things are in fact ordered by first name over here. But things are not necessarily ordered by last name. That, for example, I'm looking at Albert over here. Nolt is alphabetically after Johansson, and so this is still not fully alphabetically ordered down here. In SQL, you can order by multiple columns. You specify the first column that you want to order by, and then a comma, then the next column. So first name, comma, last name, and then it will order by the first column. And anytime there's a tie according to the first column, it'll turn to this next column over here, in this case, last name, in order to break the tie. And so I'll hit enter. And now we have something that looks like it's basically an answer to this question up here. We have the first and last name of each actor. It is in a single column. Everything is uppercase, and the column is named actor name, and the results are sorted alphabetically. So at this point, we're ready to stop working in the pSQL environment down here and actually put our command that we've worked on in this environment up here and actually run the test cases. I'll do that here in a second, but before I do that, are there any questions about what we've done so far? Yes. I'll answer that in a little bit. Good question. Any other questions? Okay. Again, just big picture overview of how I approached solving this problem is I started by reading the problem and doing things interactively in the pSQL terminal down here until I had a command that seemed like a reasonable solution to this problem at the top. Once I have that candidate command that I want to test, I will paste that into the environment up top. In order to do that, in my Vim window up top, I need to move my cursor to the bottom line. I'll press Shift G, capital G in order to do that. Then I'll press lowercase o to enter insert mode on a new line below the line that I'm currently at. And then I will paste my command from down here up into the top over here. Escape : W, and now I have my candidate answer down here. Once I have that, I can start running my test cases on this problem and see if it passes the test cases. Down here, I will Control D to leave my pSQL environment. Control D again, anytime you're in an interactive session with something, sends the end of file signal and will end that interactive session. You could also, in pSQL, it has this \Q command that you can type manually, but Control D is equivalent to \Q. Down here, I'll type ls, and you can see there's this run test.sh file, which actually runs the test cases. I will start by doing /run tests like this, and we'll see what happens. And we see that we get a bunch of failed outputs down here. This run tests file is designed not to be run directly from the terminal, though. And so even though it looks like we might be getting correct output down here, it's not actually running it on our database, and so that's why all the tests are failing. So if you try doing this like this, it might look like things are working correctly, but you're not actually running the tests in the right place, so everything is guaranteed to fail. In order to correctly run the tests, the README file, again, has the incantation inside of here for us of what we should do. It's this docker compose exec pg, and then /run test.sh. This will run the tests inside of the pg container, so it'll actually be running them in the right location. Down here, I will paste that command in right here and run that. And we get very similar looking output. For every problem in our SQL file, it'll output whether it fails or passes based on whether it passes the test case. In this case, we haven't worked on any of these problems, so it makes sense that they're all failing. But if we go scroll up to problem 1 over here, we can see that that one is still failing. And so whatever command we have inside of our 01.SQL file is incorrect. In order to figure out why it's incorrect, I'm going to walk us through this run test.sh script, what it's doing, and then we'll see how we can use the knowledge of what this run test.sh script is doing in order to debug why this is failing. This is a process that you are guaranteed to have to go through many, many times in the homework, and so it's important to make sure that you understand the details of this file right here. In order to open it, again, in my Vim window up here, I will do :tab E and then my run test.sh file. And this is the contents of this run test.sh file. This is a standard file, actually, not something that I've made for our class right here. This is a standard way of running tests on Postgres databases. And so you'll see this exact script or scripts very, very close to this in basically every Postgres project that you'll ever happen to see in your life. This starts with a failed equals false up here, create a folder called results down here. And then we are going to loop over every file in our SQL folder, calling that file problem, and do all of this stuff on that file. All of this stuff, again, using all of the random techniques, weird techniques from shell scripting that we've seen in our first few quizzes here, like command substitution and having to keep track of, will this $ get evaluated inside of double quotes or not get inside of double quotes? And in this case, it does get evaluated. What this code is essentially doing is, so it prints out the problem name, and then the important part is line 12 down here, where it runs the pSQL program. This pSQL program, again, there's no Docker anywhere inside of this .sh file, and so this is expected to be run inside of the PG container where it has access to the database. So when we do this pSQL command, it actually connects to the database. And then we use input redirection to get to pass the contents of that problem into pSQL. And output redirection to store the results in this file called result right here. The result file goes inside of this results folder down here. In the bottom terminal, I'll take a look at that results folder and we'll just see what it looks like. And you can see that there is a file down here, one file for each of the files in my SQL folder. In the SQL folder, the extension over here in the SQL folder, the extension is called .sql. And then in the results folder, the extension is .out. And the contents of these files, again, the contents of the result file is the output of running pSQL on that particular problem. So the contents of 01.out right here, the contents of this file right here is the result of running pSQL on the contents of this folder. So the first step, the first line of defense to debug the problems in this file right here are to actually look at this file right here and see what the output is. So up here, I'll do :tab-e again and results/01.out and hit enter. And this looks like the sort of output that I was seeing inside of my pSQL session. So that's good that this code is running without errors, the code that I typed in running without errors, and it's giving us output roughly like I expected. I'm going to come back over here to the run test.sh. Again, G-Shift-T, capital to go left. And then we'll talk about how it's deciding that this output is failing the test case, how it's deciding that this output right here is failing the test case. And that happens as the first step on line 13 right here, where I use this diff command to measure, the diff command takes two files as input, and it reports what are the differences between those two files. So in this case, I'm running diff on the expected. Expected is inside of this expected folder. Maybe I'll take a look at the expected folder again, ls expected like this. And the expected folder, notice, has the same sort of structure as the results folder up here, that for every file in my SQL folder, every problem in my SQL folder, every test case that I have, in this case 01.SQL, I have a similar output of what it should be, what the correct results are going to be down here, 01.out. And the diff command is just checking to see, is this file down here in the results in the expected folder, does it exactly match, like character for character, does the expected folder 01.out, does it exactly match the results folder 01.out? If these two things exactly match, then we'll pass the test case. This -z right here says that the contents of this variable is empty. The diff will only have empty output if those two files exactly match. Then we'll echo pass if the contents is empty, meaning we pass the test case. Otherwise, it'll echo fail down here. So whether we pass or fail the test case is determined by the output of this diff program. So running this diff program is another good tool to see exactly what is different between these two files. The syntax for running the diff program is something like diff and then results/01.out and expected/01.out, like this. And this will show me the contents of this command right here, so that we know whether we're going into this case or this case down here. In this case, we can see that there's a lot of output from this diff program, and I'll go over that here in a little bit. But before I want to go over the output of this diff program, I'm going to just manually look at the out folder in the results in the expected to see if I can see with my eyes what might be different between these two files. Press GT::tab-E expected 01.out. And so this one over here is my expected output. I know it's expected because it shows me the first letter of the folder right here in E. This one over here is my results output. I know it's results because it shows me the first letter, which is R. And I'm just going to press Shift-G, kind of manually go back and forth to see what are the differences right here. And the first thing that I'm noticing as a difference that's jumping out to me is this actor name up here. It did literally want the column name to be actor name with uppercases inside of it and with a space inside of it. So the first thing I'll have to do is I'll have to adjust my SQL command in order to do that. Before I go and show how to adjust that SQL command, I'll pause and see if anybody has questions at this point. Yes.
When was the results file for 01.out created?
Great question. When was this results file created? The answer is that it's when you run the run tests.sh. So here in run tests, again, it's looping over each file in the SQL folder. And the psql command right here on line 12, using output redirection right here, stores the contents of running this psql command in this file, which is stored in the result variable right here. The result variable is defined on line 10, results/problemid.out. So every time you run the runtest.sh, the first thing it does is it creates the corresponding file in the results folder, and then it populates it with the result of running psql, and then it runs the diff. So the results are created immediately before running the diff. So you should never have a problem with the results somehow being out of sync with the diff command. The expected folder, again, is provided for you inside of the Pagila homework folder. Up here, you can see that I already have the expected results up here. So this contains what all the problems, what the output should be in this expected folder. You don't have to do anything with that. Good question. Okay, so where we were at is that I was just manually looking at the output between the results and the expected. And I noticed that the actor name in the expected is actually contains capitalizations and actually contains a space in here. Manually inspecting your results is one of the, again, sort of the first steps that you should do when things are not passing. A lot of students try to run straight into automated checks about things, trying to do many things at once, but always do the manual checks before doing more automated checks. So yeah, we've manually seen that we have to get our column to actually be named actor name. How do we do that? I'm going to move on to this tab right here. I'm starting to get a lot of tabs open at once, and so using GT, going one tab at a time, is a little bit too slow for my tastes at this point. I'll notice that this is the 4th tab that I currently have open, and anytime you have a movement command and you want to move to a particular number of something, you can always type in that number and then the movement command inside of Vim. In this case, the movement command is GT to switch between tabs, and I want to go to the 4th tab, so I'll type 4GT, and it'll take me right to this tab right here. And now I'm looking once again at my select statement down here. I could try to edit this select statement directly inside of Vim, and if you are 100% sure that you know what change you need to make, that's an okay thing to do. But I'll go a little bit more step by step at this point and come back down into the terminal down here and edit things inside of psql until I have results that I'm satisfied, and then modifying things up here. So again, I'm in my terminal window on the bottom. I'll press Control-R, PSQL to get back to my psql command and hit Enter. I'm once again connected to the database. And I will use my up arrow to get back to the previous command that I had typed in. And this command right here is the exact command of my current solution to problem 1, which is incorrect. In order to make it correct, I have to figure out how to name my column over here so that it actually contains uppercase and actually contains a space. In order to do that, I'll press the up arrow, move my cursor back over here, and introduce another new weird syntax about SQL. And that is the double quotation mark. The double quotation mark is how you can say that a column name has to be literally what is contained inside the double quotation mark. So in this case, actor space name like this, double quote. This makes the column name literally actor name using the quotation mark and the uppercase letters over here. If I hit Enter now, we can see that my column name is in fact actor name, does in fact contain the uppercase letters, and does in fact contain the spaces. Press Q. Review what I did. So recall that without double quotation marks, SQL is case insensitive. SQL is case insensitive by default when there are no quotation marks. With double quotation marks, SQL becomes case sensitive, and it allows you to include spaces inside of strings like this. So double quotation marks right here. A common syntax mistake that people make, especially coming from a language like Python, where single and double quotation marks mean the same thing, is that you might use double quotation marks in a location where they're not allowed. So for example, right here, the purpose of this space right here inside of quotation marks was to combine the first name and the last name, putting a space between them. If I use double quotation marks right here, though, I'm going to get a syntax error. Syntax error right here where it says column space does not exist. Double quotation marks are always used only for the names of columns or relations inside of SQL. So double quotation marks only used for names of variables. And variables isn't quite technically the correct name, but that's the way to think about it, that a column name is like a variable name in a regular programming language, and a table name is like another type of variable in a regular programming language. So by variables here, I mean column or table names. And then single quotes only used for literal strings, In this case, I literally want the string space right here. I literally want the string space between first name and last name. I don't want a column named space to be inserted between them. And so that's why I must use the single quotation marks right there. Very common to get weird error messages by using the wrong one in the wrong location. So this will work. If I use single quotes over here in the column name, another error message, that's not valid. So double quotation marks over here, single quotation marks over here, hit enter, and now I have my column named exactly how it's supposed to be. Press Q, come back up here, and I will manually make that same change over here, actor name like this, save that, come down here, Control D, up arrow, getting back to my test cases. Okay, there we go, and hit enter. And uh-oh, we're still failing the test case. I saw it flash past over here. The 01.SQL is still failing. So let's manually visual inspect, make sure that the changes that we thought we made are happening. In order to get over to this line, this file right here, this is the expected file. Press 7GT, take me to the end over here. This is the one that's expected. It has actor name over it. The results file right here, this is the one that we just created. I'll go take a look at it. G-Shift-T to take me to the left one tab. And here you can see that I still have actor underscore name in my Vim window open over here. One of the very common mistakes that students make is that Vim, when a file is changed on disk, it will not automatically reload the file into Vim, and you have to manually reload that. That ensures that you won't accidentally lose changes that you had inside of Vim. And recall that when we run this run tests command down here, it modifies the results folder, modifies this 01.out. And so in order to reload those results, I have to in Vim :E. E stands for edit, re-edits the file, reloads the file from the disk. And I do that, and we can see that it does, in fact, load up this actor name, how it's supposed to be loaded. So that now does match with the expected over here. Okay, now it's a little bit harder for me to tell exactly what's going on, why certain lines are not correct compared to other lines. If I very quickly go back and forth between these two files, I can see that there are some lines that are obviously different because they're changing when I change my tabs over here. But this sort of manual inspection is a little bit hard to figure out exactly what those changes are. The last thing we'll do in class today is I will show you how to use that diff command to get a better visualization of what those changes are. So again, down here, I'm going to press Control-R to get my diff command back. We're diffing the results 01.out and the expected 01.out, and we get these this output like this. Again, this is literally the command that is just being run in the test case, and as long as there's any output from this diff command, we are going to fail the test case. So we can see that there is a lot of output down here. This output is all intended to be machine readable output, and so how can we get a better human readable output? And the answer is by adding this -u flag right here. I don't know what U stands for, but it gives us easier to read output. And I'll scroll up to the top up here. And now what we can see is that any line in the output down here that does not have a plus or minus is the same between both files. Anytime that has a minus is being deleted from the first file, and anytime that has a plus is being added to the second file. So this line right here, we can see that the difference between the two files is this line right here was being deleted and added over here between those two files. So the files are very, very similar, except they're summarizing the difference is that their alphabetical ordering is just a little bit different. In one file, the al comes first, and in the other file, the al comes last. So in one file, short names come first, and in the other file, short names come last. trick to solving this is not obvious, but in this case, going back to a question earlier, it's how we're ordering by things. And what we need to order by is not just first name, column, last name, not this column and then this column over here. What we need to order by is the entirety of this results at once. And so over here, I will order by actor name like this. Semicolon, I'll just comment that out over there. And now ordering by actor name, it will hopefully fix this problem and order things correctly. So Control R, rerun my test cases, hit enter. And now we can see that this first problem up here is in fact passing those test cases. The hard part about this homework is going to be that you're going to have lots of like weird edge case things sort of coming up, and you'll have to go through and figure out exactly what those edge cases are, why they are breaking, and running through this, getting a good habit, running through all of these results files, expected files, getting good habits down in order to do this. That's all the time we have for class today. So I will we'll stop here, and if anybody has questions about things, I'll take them after class. Otherwise, I'll see you all tomorrow in lab. So take questions up here after class.
I had a question about the Twitter coronavirus
Sure.
homework. I got it different because I put in the days of